The first thing I'm going to say is, I'll put good money on the suggestion because I didn't tell you to do it. But I'd put good money down that a lot of you did not start the question like this. You just started saying A equals. Now I kind of alluded to the fact that in this question, A could be a variety of different things. Right? Because A always means area, but there are lots of areas involved. There's the area we want, which is the base, right, this circle. There's the area, the surface area of the entire cone, and then there's the area of just the curved part, right? So I think it's important to actually say that, because you're about to say A on blah, 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 blah. So therefore, you want to actually say what A is. And later on, when you've got different kinds of areas that you're comparing, that's going to be vitally important. Tell me what you're actually working with. I did skip over the step in part A. Now, once I've said this, I know what the area of a circle is, but I'm not going to work with this equation. I could. There's nothing wrong with, there's nothing incorrect about it. But it's just not the most direct path. I'm after how A is not changing with respect to radius, but how A is changing with respect to height. Okay? So one of the tricky things about related rates questions is that you've got all these variables flying around and you kind of have to sift through them a little bit. Okay? Now as you'll see, because in this particular case, it's a very nice example, because you've got this nice isosceles triangle here, I can actually just substitute R for H. And then I can proceed. But if I had given you this question where it was not the case, and you will encounter questions where it's not the case, you're either going to have to use some combination of Pythagoras here, or if you were given the angles and they weren't 45 degrees, you'd have to use trig. You have to use right angle triangle. Okay, so are you ready for me to proceed? Remember where I'm heading. I'm looking for dA on dt. Okay? Now I know dV on dt, and then I know A. So how am I going to connect all of these pieces together? Suggestion? Yep.
dA on dt.
Okay. So, yes, sorry, say it again.
dA on dt equals dA on dH minus dH on dt.
dA on dt equals dA on dH.
Or times dH on dt.
Okay, very good. So, let's have a look at this. You can see part A leads me into part B, right? Because I could come back all the way to volume, but volume and this surface area are not connected in neat ways, right? They are connected, right? If volume and height are connected, and area and height are connected, that means volume and height are also connected, but the way they're connected is a bit of a mess. Why not just use this dH on dt that I already have? It's a much more direct link between these two, okay? So therefore, here I'm going to say dA on dH, which of course is 2 pi h. Okay. So now I can take this, and I've got all the pieces for this, don't I? Right? This is 2 pi h times what did we say?
3 on pi.
Okay. And I can see all this lovely cancelling that happens. Cancel, cancel, cancel. Yep. So I'm getting 6 over h. That's all that's left. So you can see, in related weights questions, again, number one, you've got to navigate the fact that so many variables are in play. And believe it or not, you'll encounter questions where there are quite a few more variables than this, certainly more variables. Secondly, you'll notice, the differentiation is not hard, right? You're often dealing with geometry, and the formulas are really easy, actually, to differentiate. You can do them in your sleep. The hard part is, you have to pick what you have to differentiate, and then combine them in the right ways to get what you want. Yeah. So, when was I interested in? When h equals 2, dA on dt is 6 on 2, which is 3. That's just a number, so now I'm going to conclude. Therefore, area is changing at, and what are my units?
3 meters squared per minute.
Great. Okay. Now, even though this question, it's not relevant, later on it will be, I will just point out that just like I rubbed it off, just like a gradient of a line can be negative, a rate of change for a quantity can also be negative. If this was, say, -3, what would that mean about the area as time progresses? That means it's getting smaller and smaller and smaller. So I might get, say, -3 here. And if that were the case, like if the question was, water's being taken out of the bottom of the barrel or whatever, I wouldn't say area, the area of that water is changing at -3 meters squared per minute. I'm using natural language. So instead I'd say something like the area is decreasing, right? So really I should have said increasing here. But that rate, whether it's getting bigger or smaller, is baked into the sign of the derivative. Yeah? So we've got all of this language already developed, and now we're bringing it back to something that's concrete. Okay? Are there any questions on these two parts of the example? Yes?
You know when you said dA on dt equals 6 on 2, can you
Yep.
just say, at that point, can you go f dash 2 equals 6 on 2?
So you're thinking of... Are you thinking of writing this? Is that what you're thinking of writing?
I wrote f dash.
Okay, so let's pause for a second. I've already kind of put my cards on the table as to what I think is the clearest way to write it. I probably would not write f dash, whatever, because which f are you talking about? Like, I mean, okay, I suppose you could define an f, but there are so many things in this whole question that could legitimately be called f. I think that's a bit misleading. This is a little bit better, because like, oh, now I'm looking at area, but then it's like area with respect to what? Like, I know I've written area with respect to time. That's the only a derivative that I have. But I could have written, oh, actually, sorry, I take that back. I have this derivative. I have two derivatives of a with respect to two different variables. So I am going to lean away from this, and I'm just going to say, tell me what you're differentiating with respect to what.